Now I am going to teach very important 5-mark question, that is Young double slit experiments. Okay, already I sent the video for the Young double slit experiments by using PDF. Okay, for the derivation purpose I sent this video again to you. It is very important 5-mark questions. Young double slit experiments. For this we consider one opaque medium. This opaque medium, there is having this two hole, so it is behave as a source S1 and S2. Okay, so it is nothing but it is one of the opaque medium. That medium we are making the two hole to act as a source of the light S1 and S2. Okay, these are called slit. Okay, these are called slit. We are making the two holes on the opaque medium. Okay, so that is slit S1 and S2, that is a double slit. So this experiment is Young double slit experiment. Okay, so the width of the each slit, the width of the each slit is 0.03 millimeter. Okay, the width of the each slit, it has a value 0.03 mm, and the two slits are separated with the distance is 0.3 mm. 0.3 mm. Okay, students, right? So like this here, this S1 and S2, it is behave as a coherent sources. It is behave as a coherent sources. Okay, to obtain the required interference pattern, here it is behave as a coherent sources. Already I taught to you what is in by coherent sources. The light coming from these coherent sources, it has a same phase. Okay, it has a same path difference. Okay, that is called coherent sources. It has a angle is the same, it has a wavelength is the same, it has a phase difference is the same. So that type, that light is called coherent sources. Okay, here the S1 and S2 it is gives a coherent sources. So from the source, the light is passing through the slit S1 and S2. Here it is also produced a wavefront. This wavefront S1 and S2 is spread out and overlapping on the right hand side of the opaque medium. Okay, right hand side of the double slit. Now we are taking one screen. This screen is placed in front of the opaque medium. Means that overlapping light is incident on the screen and it is produces a fringes, that is called interference fringes or band. Interference band or interference fringes. So using an eyepiece, we can see that interference fringes, the light is empty light. Okay, this is one of this, and then it is overlapping and produce a interference fringes from the center to this point P. Here there is produce a interference fringes like this. Okay, friends. So like this, we are taking the center of the screen, that is O. The wavefront from S1 and S2 travel the equal distance and arrive in phase, and it also produces a interference fringes on the screen. So at a point O, there is produce a fringe that is called central bright fringe. Okay, it is producing interference fringes like this. It is producing interference fringes, that is dark and bright consecutively. Like this, here we can say at a center it is to produce a central bright fringes. At a center point O, it is to produce a central bright fringes. So from the center, these fringes it is disappear and there is a uniform illumination on the screen when one of the slit is covered. Now one of the slit is covered means here these fringes is disappear and there is a uniform illumination on the screen. Okay, there is a uniform illumination on the screen. Okay, so this is shown clearly the band due to the interference. Okay, when one slit is closed, means here this fringes is disappear in the uniform illuminations on the screen. Okay, so from this we conclude that here there is produced a interference, there is a produced a fringes due to the interference. When the two sources are open, at the time only there is a produced a interference. Okay, so when the two sources are interfere, there is a produced a interference fringes. Okay, students. So by using this concept, I am going to teach very important 5-mark question. By using the Young double slit experiment, we are going to calculate the equation for path difference. Equation for the path difference. So by using Young double slit experiments, we are going to derive equation for path difference. Okay, that is not a letter delta. Path difference delta. Okay, students. So the diagram we are taking from the Young double slit experiments. Already I explained to you the S1, S2 are the coherent sources, and then the sources, it has a wavelength is lambda. Lambda is a wavelength of coherent sources. Okay, we are taking the distance between the slit. The distance between the slit is noted by letter D. The center of the slit is noted by letter C. C is a center of the slit. And then here the screen is placed at a distance capital letter D from the vacuum medium, from the slit. From the slit, the screen is placed at a distance D. Okay, so when the light is allowed to pass it through the slit, these are the coherent sources. So it is overlapping and produce the interferences. Then at a point P, there is produces a interferences. The point P is having the distance y from the center of the screen. Okay, so it is producing interference on the point P. It is having distance y from the center of the screen. So here the waves from S1 and S2 is meet at a point P, either in phase or out of phase, depending upon the path difference between the two waves. Okay, so the light is passing through the S1 and S2. Here this is reach at the point P. It may be in same phase or out of phase, is depending upon the path difference between the two waves. So to calculate the path difference of the two waves, we can note the path difference delta between the light waves from S1 and S2 to the point P is calculated by using the formula. We can take this wave is travel from this point to this point, and this wave is travel from this point to this point, then it is reached to this point. So the path difference between the two waves, it is also calculated by using the wave is travel from S2 to P minus S1P. What is the path difference? The path difference means it is the difference between the two waves. It is the difference between the length of the two waves. It is the difference between the according to this the length of the two wave. So S2 is delta is equal to S2P minus S1P. So to find the path difference, we draw the perpendicular line from S1 to the S2P. We draw the perpendicular line to calculate the difference between the two rays. To calculate the difference between the two rays, that is to calculate the path difference between the two waves, we are draw the perpendicular line from the S1 to the S2P means it is meet at a point is M. It is meet at a point is M. So from this concept we can write what is S2P. S2P is equal to S2M plus MP. And then we know that the S1P is equal to MP. Okay, we draw the perpendicular line means this S1P is equal to MP. So for calculate the values of S1P, we are taking it is equal to MP. It is substituted in this equation means we can write delta is equal to S2P minus what is it mean by S1P? S1P is equal to MP. So by using this concept, what is the meaning for S2P minus MP? It can be written as delta is equal to S2P minus S1. S2P minus MP means it can be written as that is S2M. This is the remaining values S2M. So the path difference delta is equal to S2M. So for calculate the value of path difference, we are taking the angular position of the P from C. The angular position of the C from and the angular position of the P from C means it has the angle is theta. It has the angle is theta. Okay, so the theta is equal to angle of OCP. Theta is equal to angle of OCP. The angle of OCP is equal to theta. So the angle theta from the geometry, the angle of OCP, it is also equal to the angle of S1, S2, M. Okay, so it is equal to the angle of S2, S1, M. That is also noted by letter theta. Okay, students. So from the geometry we are taking like this. Here if it is having the angle is theta means this angle is also equal to this angle. So we can write the angle of OCP is equal to angle of S2, S1, M. So it is also equal to theta. So in right angle, triangle, we can take the triangle S1, S2, M. Okay, we take the triangle S2, M, S1, or that is S1, S2, M. We take the right angle triangle S1, S2, M. The path difference is S2M. Okay, so the S2M is one of the parts of the triangle S1, S2M. So the path difference is S2M. So for calculate the values of the S2M, we know that in this triangle, what is S2M? S2M is one of the opposite side. Okay, in this triangle S1, S2M, this is a theta. So what is the values of the S2M? S2M is one of the opposite side. So we are going to calculate the values of sin theta. What is sin theta? Sin theta is equal to opposite side S2M divided by hypotenuse. This is which is hypotenuse? Hypotenuse means this part is only hypotenuse. S1, S2 only hypotenuse. Okay, because the 90 degree is here. So opposite to the 90 degree is the hypotenuse. So the S1, S2 is a hypotenuse. Already you know the S1, S2 it has a distance is d. So we can write that is d. So from this, what is the values of the S2m? S2m is equal to d sin theta. S2m is equal to d sin theta. So already we know that S2m is equal to d sin theta. Here the theta is small. We know that the theta is a small value. So if theta is a small value means we can write sin theta is equal to tan theta, approximately equal to tan theta. So it is also approximately equal to theta. We know that sin 0 degree it has the same values of tan 0 degree. So sin 0 is equal to 0, tan 0 is equal to 0. So we can write sin 0 degree is equal to 0. So by using this concept we can write sin theta is approximately equal to tan theta. It is also approximately equal to theta. Okay. So from the concept we are taking from the right angle triangle. We are from the right angle triangle OCP. We are going to calculate the values of tan theta. So tan theta means that is the opposite side divided by adjacent side. For the triangle OCP, which is opposite side is OP divided by adjacent side. Which is adjacent side? This is a 90 degree. This is 90 degree. Opposite to the 90 degree is hypotenuse. So this is the adjacent side. The adjacent side is one of the OC. Already you know what is the meaning for OP. OP means that is y divided by what is the values of the OC, that is equal to d. So y divided by d. Tan theta is equal to y divided by d. So we can write tan theta is equal to y divided by d. We know that sin theta is approximately equal to tan theta. So we can write the S2m is equal to d. The sin theta is approximately equal to tan theta. So we can write dy divided by d. Already you know what is the values of the S2m, that is equal to delta, path difference. The path difference delta is equal to dy divided by d. Okay, students, we know that the S2m is equal to delta. So delta is equal to dy divided by d. This is a derivation for the path difference. So by using this concept, we are going to, based on the condition of the path difference. Condition on the path difference, there is a bright or dark fringes. So already you know the condition for the bright fringes and dark fringes. So it is substituted in this equation. We can get the path difference for the bright fringes and dark fringes. Okay. So first we are going to discuss about condition for bright fringes. Condition for bright fringes. So what is the condition for the bright fringes? The path difference delta is equal to n lambda. For the bright fringes, delta is equal to n lambda, where n is equal to order 0, 1, 2, and so on. Okay, so we know that this is a formula for the path difference by using the Young double slit experiments. Okay, for the condition for the bright fringes, delta is equal to n lambda. So if there is produces a bright fringes at a point B, if there is a bright fringes means we can write n lambda is equal to dy divided by d. Delta is equal to n lambda for the bright fringes. So we can write, if there is a bright fringes means n lambda is equal to dy divided by d. From this we can write what is the values of the y, at which distance is this produce a bright fringes. So the y is equal to n d lambda divided by d. So this is a distance from the center point. So in this distance it is produce a bright fringes. Okay, this is a condition for the point P to be a bright fringes. The distance is the distance of the nth bright fringes from the point O. Okay, so for the values n is equal to 1 means that is with the first bright fringes, n is equal to 2 means it is with the second bright fringes. So next condition for the dark fringes. So what is the meaning for dark bright means? Bright fringes means it has intensity is maximum, it has intensity is minimum. Okay, maximum minimum. Right? The condition for the dark fringes, already you know the formula for the dark fringes. The path difference delta is equal to 2n minus 1 lambda divided by 2. 2n minus 1 lambda divided by 2. According to the Young double slit experiments, the path difference is delta is equal to dy divided by d. If there is a dark fringes, okay, where there is a dark fringes, if there is a dark fringes means it has a condition that is 2n minus 1 lambda divided by 2 is equal to dy divided by d. At what distance there is produces a dark fringes, and you can calculate the values of y means y is equal to 2n lambda divided by 2, you can multiply this. Okay, minus lambda divided by 2 into d divided by d. Okay students, you are multiplying this and you are taking this part to left side means it will become as 2n lambda divided by 2 minus lambda divided by 2 into d divided by d. So in next step it can be written as 2n lambda minus lambda divided by 2 into d divided by d y is equal to y. In next step we are taking lambda on outside means it will become as 2n minus 1 divided by 2 lambda d divided by d is equal to y. Okay, this is one method students. In another method we can write this is 2n minus 1 lambda divided by 2. In next step it can be written as y is equal to 2n minus 1 lambda divided by 2 d divided by d. Okay students, and then next step we can write this divided by 2, it will be written as 2n minus 1 divided by 2 lambda d divided by d. Okay, so which method you are understanding, you can choose. Okay, that is 2n minus 1 divided by 2 lambda d divided by d is equal to y. This is for the condition for the dark fringe. Students, you can listen it. So this is a diagram for how there is a forming the bright and dark fringes. It is a diagram for produce a bright fringes. So in this diagram you can choose, this is a crest of the one wave, this is a crest of the another wave. The crest and crest meet, trough and trough meet, so there is to produce a bright consecutive interference. So this is a diagram for the dark fringes. In this, here the crest of the one wave is meet trough of the another wave, so there is to produce a dark interference. There is to produce a fringe, that is one of the dark fringe. Here the crest, trough meet, so there is to produce a interference, that is one of the bright fringes. Here there is to produce a interference, this is one of the dark fringes, because the crest is meet with the trough. Crest meet with the trough. Okay students, so this is a formation of bright and dark fringes diagram. Students, up to this point the answer for the question, explain the Young's double slit experiment setup and obtain the equation for the path difference is over. Then next question, obtain the equation for bandwidth in Young double slit experiment. Okay, you need to draw the same diagram and need to write the answer up to the path difference. Then you need to continue this question for calculate the bandwidth. Is not a letter beta. What is meant by bandwidth? Bandwidth is defined as the distance between two consecutive bright or dark fringes. It is the distance between the two consecutive bright or dark fringes. Okay, already you know what is the meaning for consecutive. So you are taking this is the white color is a bright, dark color is a dark fringes, means the distance between the two consecutive dark fringes, or the distance between the two consecutive bright fringes is a bandwidth. So for calculate this, the distance between the n plus 1 and n consecutive bright fringes. The beta is equal to y of n plus 1 minus y of n. Okay, so that is we are taking consecutive bright fringes. For the bright fringes, it has a value y is equal to, from the Young double slit experiments, y is equal to n d lambda divided by d. So first we are going to calculate the values of n plus 1. Okay, so the y is equal to n plus 1 means substitute n plus 1 in n, so n plus 1 into d lambda divided by d minus next y of n, that is n d lambda divided by d is equal to beta. So in next step we are multiplying this. First you are multiplying with the n means n d lambda divided by d. Next you are multiplying with the plus 1, that is d lambda divided by d minus n d lambda divided by d, means n d lambda divided by d minus n d lambda divided by d cancelled. So what is beta? Beta is equal to t lambda divided by d. Okay, this is a bandwidth for the consecutive bright fringes. So similarly we can calculate the distance between n plus 1 and n of consecutive dark fringe. That is for dark fringes y is equal to, that is beta is equal to y of n plus 1 minus yn. For the dark fringes it has y is 2 minus 1 divided by 2. Okay students, lambda d divided by d. So instead of n we are going to apply n plus 1. So beta is equal to first y of n plus 1, that is 2 into n plus 1 minus 1 divided by 2 lambda d divided by d minus y of n, that is 2n minus 1 divided by 2 lambda d divided by d. So in next step it will become as, so from this term these will become as beta is equal to 2 multiply this n, next plus 2 into 1, 2 into n, that is 2n, 2 plus 2 into 1, that is 2 minus 1 divided by 2 lambda d divided by d is minus, this will become as 2n minus 1 divided by 2 lambda d divided by d. Next step the beta is equal to, this will become as 2n plus 2 minus 1, that is plus 1 divided by 2 remaining lambda d divided by d minus 2n minus 1 divided by 2 lambda d divided by d. So in this the lambda d divided by d is common, so it will be taken outside. So beta is equal to lambda d divided by d. What is remaining? That is 2n plus 1 divided by 2 minus 2n minus 1 divided by 2. Next step, beta is equal to lambda d divided by d. Here dd, 2n plus 1 divided by 2 minus 2n minus 1 divided by 2. So it will become as 2n plus 1 minus of 2n minus 1. Next step, beta is equal to lambda d divided by d. 2n plus 1 multiply this minus means that is minus 2 plus 1 divided by 2. So beta is equal to lambda d divided by d. This minus 2n plus 2n cancel that. Okay, remaining plus 1 plus 1, so that is 2 divided by 2. So it is cancelled, means beta is equal to lambda d divided by d. So this is a bandwidth for the consecutive dark fringes. Students, and then important 3 more questions. What are the conditions for obtaining clear and broad interference band? So first condition, the screen should be as far away from the source as possible. Okay, this screen, it must be placed as far away from the source of possible. Then the wavelength of light used, it must be larger. The wavelength of the light used must be larger. Next, the two coherent sources S1 and S2 must be as close as possible. Already you know it has a distance is 0.3 m only. Okay, the values of d is equal to 0.3 m only. So it must be close as possible. These are the conditions to obtaining the clear and broad interference of band. Thank you, students. It is important 5 more questions, students. So 5 more questions I completed in this video. So all the students, you must watch it and prepare well for the examination.